At each station in the design lab, there are toolboxes filled with many assorted hand tools. It is important that you know the safety precautions and procedures and also proper use of these hand tools before beginning your project work. Personal protective equipment, or PPE, and safety precautions that are required for the lab are as follows. Be sure to wear long pants as well as closed-toed shoes when doing any lab work. Tie back any long hair so it doesn't get caught, as well as secure any loose clothing or jewelry. Wear hearing protection when operating machinery, and always wear safety glasses when inside the lab. Using the right tool for the job is very important because if the wrong tool is used, it can not only be damaging to the tool, it can also be harmful to the operator. If a chisel is used to pry things open or to drive in screws, such as a flathead screwdriver, it may damage the fine-edged tip. If a scribe, which is used to mark lines in material like a pencil, is used as a punch to mark a drill location, it may bend or break the tip. And if a screwdriver or wrench is used as a hammer, it may break internal parts. To make sure you're aware of what's going on around you in the lab when completing your project work, it is very important that you keep your work area clean before, during, and after completion. Finally, it is important that all tools are replaced with care and in their proper location when finished. Be sure to not remove any tools from the lab, and never work alone. If there are any tools missing from your station before you start working, simply write it down on the whiteboard and contact your shop supervisor. These steps ensure all tools are replaced and the next student can easily find and use them. Planning your project before construction is very important to ensure the construction process runs smoothly. Having the required dimensions written down or in engineering drawings allows for quick reference. When cutting material, first measure the proper distance using a measuring tape or ruler. Mark it with a small dash of a pencil or a scribe. Then place a square on the wood on the free side. Line the square up with the dash and complete the line. This makes a perfect perpendicular line to the free side. Then measure the distance in 2 locations on the line, so make sure it is straight and in the correct location. When drilling a hole, it's helpful to use a punch to provide a guide for the bit so it doesn't move while drilling. Simply mark the location you need to drill, line the punch up with the marked location, and hit it with 1 stroke of the hammer. Now that small indentation is where you'll place your drill bit so it doesn't slide around while you're drilling. Clamping helps secure the material being worked on so alterations can be made easily and accurately. If a single clamp is used, it provides a pivot point for the material and it may move. So adding a second clamp removes this pivot point and secures your material to the table surface. Also, before drilling or any other alterations are made, it may be helpful to add a small piece of scrap wood underneath so you don't drill into the table surface. A vise is used as a stationary clamping device that works by first loosening the turnstock so the front portion can slide out, placing your material inside the vise, sliding it back on, and tightening it with the turnstock. This holds the material securely in place. A vise may be used to secure material for drilling or cutting, and it can also help to hold material in place when gluing or fastening. In the design lab, there are 4 different hand saws for you to use. 3 located in the station's toolboxes, which include the utility saw or carpenter saw, the fine detailed saw, and the hack saw. The 4th being the coping saw found in the supervisor's toolbox. In general, saws with larger teeth, like the carpenter or utility saw, cut much faster with a rough and coarse cut. and saws with small teeth, like the fine detail saw, cut a much more precise and clean cut. Try to avoid cutting your wood parallel or perpendicular to the free edges. Cutting on an angle adds great ease, and always remember to make your cut at or below waist level.
If you look at the teeth of a saw, the direction they're pointing in is the direction the saw cuts in. On the fine detail saw, they point towards the handle, which means they cut on the pull stroke. But for the hacksaw, the teeth point away from the handle, which means the hacksaw cuts on the push stroke. So that would be the direction you'd want to apply your force in when cutting.
The utility or carpenter saw is used to cut across wood or soft plastic.
Secure your work to the edge of the table with the waste end hanging off. Use a few pull strokes of the saw to get the initial cut started. These pull strokes don't actually cut the wood, they just provide a small groove which helps to start the cut easier. Only apply force on the push stroke and pull up and back on the pull stroke to cut efficiently. Near the end of the cut, place your hand over the saw, clear of the blade, but while holding the waste end so that tear out doesn't occur and a clean cut results.
The hacksaw is used to cut metal and works on the push stroke. This small hacksaw found in the toolbox is used for smaller jobs like cutting the ends of bolts or screws off. If you have larger jobs like working with big pieces of metal or pipe, you'd want to use the supervisor's large hacksaw.
When cutting with the hacksaw, make sure to always use the tension section of the blade. If the blade ever needs to be replaced, make sure the teeth are always pointing away from the handle as the hacksaw, again, cuts on the push stroke.
Fine detail saws cut on the backstroke and are used to make fine, detailed precision cuts in wood or plastic. They're great for cuts that come to a corner or in very small pieces. Be sure when starting to use one push stroke to get an initial groove, then follow this push stroke with several backstrokes applying force to finish the cut, while holding the waste end so it doesn't splinter or pull. The drill press is one of the machines that's used in the design lab. It's a large stationary drill with a movable table surface and variable speeds. It can also be equipped with many different drill bits that make it a very versatile machine for the lab. Before using the drill press, make sure you always have your PPE, including safety goggles, hearing protection, tie back any long hair, clothing, or jewelry, as it may get caught in the moving bit. If anything does get caught in the moving bit, it is equipped with a large red stop button that can be easily hit if necessary.
Some of the bits that can be used on the drill press include the twist bit, which can be used on many assorted materials, including soft plastic or metal, as well as wood. There's also the spade bit, which is used on larger pieces of wood, such as lumber. The countersink bit, which provides a tapered relief for a screw head after the initial screw hole has been drilled. And the hole saw, which will be covered in more detail at the end of this video. There are two types of drills used in the design lab. The first is a keyless chuck drill, which is used by first putting the bit in, securing by hand loosely, and then tightening with the upper collar by turning clockwise. To remove the bit, simply hold the collar, turn counterclockwise, and replace the bit in its proper location. The second type of drill press is one that requires a chuck key, which is found on the left-hand side of the drill, and is used by simply putting it in the holes, lining the teeth up, and turning it clockwise until the bit is secured. To remove the bit, simply put the chuck key back in, turn counterclockwise, and slide the bit out.
Before drilling your material or stock, you're going to want to clamp down and secure it to the table surface. You can either use the onboard clamping system found on the drill press itself, or you can use a small vise and hold it down with the onboard clamping system. Also, it may be helpful to put a sacrificial piece underneath the piece you're looking to drill. Doing this helps prevent tear out on the underside of the stock. One drill press specific clamping method is using the strap clamp setup, which is found in components on the wall behind the drill press. The first is the T-nut, which slides into the tracking system on the left and the right-hand side of the table surface. There's a threaded location where various length studs, ranging from short to long, can be threaded, and also a nut that gets threaded on top. There's also the strap clamps themselves, which range from small, medium, and large, that have a grooved teeth section, which meet up with the step blocks. With small to large strap clamps and step blocks, a wide range of material sizes can be clamped. First, take your T-nut and thread on the desired length stud. Once it's threaded, slide it in to the slotted section on the table surface. Next, take your step block and your strap clamp and meet the teeth up at the desired height. Then, thread the regular nut on top, securing the strap clamp to the top of a vise. Do this on both sides so the vise is held securely. So once your stock is secured and properly clamped in place, it is now time to adjust the table height so that when the bit is turned on, it can reach your stock. On the column behind the drill's surface, there are two bars that need to be turned counterclockwise. This loosens the table surface so it can move side to side as well as up and down. To move it up and down, simply turn the crankshaft on the right-hand side clockwise to go downwards and counterclockwise to bring it upwards. Then position the table surface in line with the drill bit. Once it's in the correct location, turn the bars on the left-hand side of the drill clockwise to tighten the table surface. You can also set a nominal depth for the drill bit to travel by using the depth stop on the left-hand side of the drill. Once your table height is secured and so is your stock, you can now dry run the bit to make sure it lines up with the proper location before starting your drill. Keep in mind that different speeds can be used on the drill press depending on what bit you're using, as well as the stock that you're actually drilling into. For more information on this, talk to your shop supervisor before changing any speeds or bits. Press the green start button to turn on the drill. First, use the feed levers to lower the drill bit slowly to check the alignment once again. Raise it back up when you're sure it's in the proper location and bring it down through the stock. When you get near the bottom of the hole you want to drill, reduce the feed speed so tear out doesn't occur and slowly bring it back up through the material. When the hole is done, turn the machine off using the red stop button and wait for the bit to completely stop moving before removing any material or debris. Brush any debris away with the hand brush, and when the bit is cooled, remove it from the chuck using the key and place it on the left-hand side of the drill. One of the specialty bits available for use is the hole saw, which cuts perfect round holes into stock. The main component of the hole saw, called the arbor, consists of a twist bit or pilot bit and a threaded location to screw the hole saw on. Once it's screwed on, line up the two holes of the hole saw with the two pins on the arbor, and once they're lined up, simply snap it into place, locking it securely. Once it's locked, place it into the chuck of the drill by either using a chuck key or a keyless chuck. Once it's securely in place and your hole has been cut, use the holes on the side of the bit to aid in removing the material. One of the machines available for use in the design lab is the bandsaw, which consists of one large circular blade that wraps around a wheel in the upper and lower wheel housings. These wheels ensure that the blade is always being forced downwards in the direction that the teeth point. The wheel housing door should not be opened. If a problem occurs or the blade breaks, contact your shop supervisor for assistance. Before using the bandsaw, make sure you always have hearing protection as well as eye protection. Tie back any long hair, clothing, or jewelry as it may get caught in the downward forced blade. If anything does get caught in the blade, it'll want to pull you into the table surface. So because of this, the bandsaw is equipped with a large red stop button that can easily be hit with an open palm if necessary. Before cutting your material, there's a few things on the bandsaw that need to be set up to ensure a safe cut.
The first thing to do is adjust the blade guard height, which is done by loosening the adjustment knob and then turning the crank wheel counterclockwise to raise it up and clockwise to lower it. The blade guard should be no more than 1/4 inch above your material. Once the guard height is set, simply tighten the adjustment knob, locking the guard in place.
Next up is the onboard fence system, which is equipped with a local ruler as well as a viewing window, which allows you to set the wood at nominal lengths to be cut. It also is equipped with the fence itself, which results in a straighter cut.
Simply loosen the lever, slide the fence freely, and lock it in place once it's in the proper location. The table surface can also be angled downwards by simply turning the crankshaft underneath the table itself counterclockwise, and then turning the adjustment knob clockwise while reading the onboard protractor for the desired angle, and locking it in place with the crankshaft.
Always make adjustments to the blade guard, fence, and table surface while the machine is turned off. Never make any of these adjustments while the blade is moving. And in the rare event something breaks, such as the blade or another component, quickly turn the machine off and contact the shop supervisor for assistance. Make sure the piece you're looking to cut has a flat bottom. If it were to have an angle and placed on the table's surface, it might kick back from the blade of the bandsaw. Before cutting your material, you should mark the waste side with an X. This is helpful because the bandsaw's blade has an associated thickness, and this thickness is lost in the cut. So if the blade is placed on the wrong side of the X, you can come up short in your final measurement. So place the majority of the blade on the side with the X so it can be sanded down to the proper size if necessary. Before starting the machine, it may be helpful to dry run your material through the saw to make sure it lines up with the blade correctly.
Turn on the machine's ventilation, followed by the bandsaw itself. Place your material on the fence system, making sure your fingers are never in line with the blade. And slowly push the material through. Don't push too hard. The blade will do most of the work. And don't let your fingers get within 4 to 5 inches of the blade. If they do, use a push stick to aid in helping the material through the blade. Once the cut is complete, turn the machine off, as well as the ventilation, and wait for the blade to come to a complete stop before removing any debris or material. Use the push stick to remove any immediate material away from the blade, and then use the brush to remove any small sawdust.
One of the tools that can be used along with the bandsaw is the miter gauge, which is placed in the miter slot on the table surface. This helps you guide the wood through the blade straight with the aid of the fence, and also lets you set nominal angles for the wood to be cut at through the bandsaw. There are a few types of cuts that can be made on the bandsaw, some of which include cross cut, rip cut, and relief cut.
The cross cut is made perpendicular to or across the wood grain. The rip cut is made parallel or along the wood grain.
Finally, relief cuts are made perpendicular to arches or non-straight cuts. This is done because the bandsaw has a very wide blade, and if arches are attempted, it may bend or break the blade, as well as burn the wood. Be sure not to put your relief cuts too deep into the material, past the main cut line. If this is done, a sloppy final cut may result. As shown here, relief cuts allow small segments to be broken off, rather than one large piece. This eases the work of the blade through the overall cut, and provides a very clean final arch. It's very important that you don't try and back your blade out of a long cut for any reason, as it may burn the wood or make an uneven cut. Plan ahead to include relief cuts so the material can be repositioned if necessary, such as when making a long cut. One of the machines available for use in the design lab is the belt and disc combination sander, which consists of a belt sanding surface on the left-hand side and a disc sanding surface on the right-hand side. Although there are two sanding surfaces on this particular machine, it is not permitted to be used by more than one individual at a given time. Before operation of the combination sander, make sure you have your hearing protection, eye protection, and a face shield. Tie back any long hair, clothing, or jewelry so it doesn't get caught in the moving surface. If anything does get caught in the moving surface, as well as material or debris, don't try and dislodge it while the machine is running. Simply turn the machine off and contact your shop supervisor. If you require the surfaces to be set at an angle, simply loosen the crank on the right-hand side of the belt portion while following the angle readout and lock it in the desired location. To change the angle of the disc portion, simply loosen the two knobs, the one on the front as well as the one on the back, and remove the stop from the table surface, and simply set it at the desired angle and lock the front and back knob, securing the table. And always return the two tables back to the 90-degree position when finished. When using the belt portion of the combination sander, it's important to know that the belt travels downwards towards the table surface. Because of this, you want to keep your material flat and your fingers away from the moving sanding surface so they don't get pinched into the machine. Also, when operating, you want to move your material side to side so that it doesn't burn a hole into the sandpaper and also it doesn't burn the wood itself. When using the disc portion of the combination sander, it's important to recognize that the disc itself rotates counterclockwise towards the front half of the machine. This is important because when you place your wood on the table surface, you want to place it on the portion of the wheel that has the downstroke, or on the front half of the wheel. It is also important to keep your fingers clear of the wheel so they don't get caught and pinch. And much like on the belt, you want to also move your material side to side, making sure not to pass the midpoint so it doesn't burn the sandpaper or the wood. Before turning the machine on, it is important to make sure the table surfaces are clear of any debris, as well as locked in their proper location. Turn the onboard dust collector on, as well as the machine's motor. Then, start the sanding by going slow, moving the material side to side, while keeping it firmly on the table surface. Make sure not to force the material into the sander, as it may buckle and push your fingers into the sanding surface. And with the disc side, remember to move the material side to side, much like on the belt, but making sure not to pass the midpoint of the sanding disc. Use the sander's eraser to clear any extra sawdust or debris from the sanding area. Remember to hold it firmly while keeping your fingers clear, as it may get pulled into the machine. And using the eraser keeps the sander clean and gritty, helping it run efficiently. Once your sanding is complete, turn the machine's motor off, followed by the dust collector. Wait for the belt and disc to come to a complete stop, before cleaning any extra material, sawdust, or debris away with the hand brush. One of the tools that can be used along with the combination sander is the miter gauge, which is placed in the miter slot on the table surface of the belt sander, as well as the disc sander. The miter gauge helps slide material back and forth along the sanding surface, as well as set nominal angles for material to be sanded at. One of the machines available for use in the design lab is the scroll saw, which allows for small, detailed, intricate cuts to be made in thin pieces of stock. It operates by having a variable speed reciprocating blade held in tension above and below the table surface. It has a small jet of air that is placed at the cut location to keep it free of any debris and keep it visible. It also has a variable speed knob which allows slow or fast reciprocation to be set. Before operation of the scroll saw, make sure you have your hearing protection, eye protection, tie back any long hair, clothing, or jewelry so it doesn't get caught in the reciprocating blade. If anything does get caught in the blade or the blade breaks, which can result from too much force being applied or too sharp of turns being attempted without relief cuts, just simply turn the machine off and contact the shop supervisor. The scroll saw's head can be tilted to provide an angle to your cut by loosening the crank under the table, turning the adjustment knob, and tightening the crank, locking it in place. It's important the saw's blade is in tension. First, check that the blade is held under the thumb screw's pin. Then, tighten the top thumb screw, as well as the bottom. Tighten the tension lever and check the tension. Next, place your material near the blade to adjust the blade guard's height. Simply loosen the thumb screw and lower it so it's just above the material. Then, place the jet of air close to the cut location to clear away any debris. Keep in mind that at lower speeds, the scroll saw cuts very rough, but at higher speeds, it may burn the wood. Never make any of the adjustments while the machine is running. Simply power the machine down to change any of these settings. Also, make sure your wood always has a flat surface to lay level with the table. Before starting your cut, make sure the table surface is completely clear of any extra debris and locked in place. Also, make sure the blade's teeth are pointing outward and down. Start by powering the machine on at a low speed and raise it until it reaches the desired speed. Slowly enter the cut, always making sure to keep your fingers 3 to 4 inches away from the moving blade. If long curves or sharp cuts are being attempted, make relief cuts to ease the work of the blade and to prevent wood burn. Never keep your fingers directly in line of the blade, and only back the blade out of a cut when the machine is turned off. Once your cut is complete, turn the machine off and remove the blade's tension to take away any added stress. Then, clear away the table surface of any sawdust or debris using the hand brush. One of the unique features of the scroll saw is that it allows you to cut out shapes in the middle of material, much like the square on the left-hand side. Simply drill a hole inside the square so the blade can pass through. Remove the saw's blade by using the thumb screw on top and below the table surface and simply remove the blade. Then place the drill hole over top the hole in the table and send the blade through, locking it in place with the thumb screws. Flip back the lever, putting it in tension, and turn the machine on at a low speed, raising it to the desired speed. Cut the shape from the inside out, working from the drill hole to the outer edges. Again, Remember to keep your fingers 3 to 4 inches away from the cut location. Try to work by cutting out small segments of the inner shape. This eases the work of the blade and also makes for a cleaner final cut. When the cut is complete, turn the machine off and remove the tension from the blade. Loosen the blade's thumb screw from above as well as below to retrieve the blade from the machine. Remove the enclosed material and your cut is complete. Once you're satisfied with the final product, remove any extra material or debris from the table surface using the hand brush. Make sure to replace the blade by locking it in place from below and above so it can be safely used by the next student.